Okay students, so again we are back to discuss this afternoon key. So again this is a session in which we just give the key but not the detailed solutions, of course. So we can quickly check the key of the questions that came in yesterday's GATE examination in the afternoon slot for mechanical. Okay, so now they have asked one question about this heat transfer dimensionless number. So they have asked about Stanton number, and you know the Stanton number is nothing but Nusselt number divided by this Reynolds number into Prandtl number. Okay, so this is the correct expression for this Stanton number. So it's directly straight away the formula. So you can just keep writing Stanton number is equal to Nusselt number divided by Reynolds number into the Prandtl number. So Nu by Re into Pr. Next, there's one question from this fluid mechanics. The value of rho dou square U by dou X plus dou UV by dou Y, and given this flow is incompressible flow. So if the flow is incompressible, then definitely the divergence of this velocity vector has to be 0, which means, you know, for a two-dimensional flow, dou U by dou X plus dou V by dou Y has to be 0. So here if you try to apply this, dou U square by dou X is nothing but 2 times of U into dou U by dou X plus, if you differentiate this partially, you get U times of dou V by dou Y plus V times of dou U by dou Y. This has to be 0, correct? So from these two expressions, if you take one dou U by dou X here, and then if you take one U common from these two terms, you get U times of dou U by dou X plus dou V by dou Y plus V times of dou U by dou Y is equal to 0. And of course, since the flow is incompressible, you can clearly sense this is the continuity equation and this has to be 0. So if you simplify the things, we get the final equation as U times of dou U by dou X plus V times of dou U by dou Y. This is the expression that you have, which is equivalent to this case whenever the flow is incompressible. Clear? Yeah, U into dou U by dou X plus V into dou U by dou Y. Okay, so this is what we have. Again, there is one question from this psychometry. So they are asking you for some total pressure is given 101 kilopascals, temperature is also given 300 Kelvin, and relative humidity phi is 60%. That's what it's given, and they are asking you for specific humidity. Sorry, specific humidity is nothing but kg of water vapor that you have per kg of dry air. Okay, so this is what they're asking you for, and of course if you have phi, then that means phi is equal to PV divided by PV sat. This is what you can always write, and of course 3.6 is given as the saturation pressure. PV sat is given, how much is this? 3.6 kilopascals. So if you substitute kilopascals PV saturation here, and of course if you substitute pi, you will be getting PV, and PV if you get, you know, total pressure also, so you can write just omega is equal to 0.622 divided into PV divided by total pressure minus PV. This is what you have, and total pressure you have here, PV you will be getting from this equation, and of course 0.622 is just a constant. So if you perform the calculations, you will end up with the answer which is equal to 0.01359 kg of vapor per kg of dry air. This is what we have. Okay, so this is the value for omega, of course, for this particular question. Okay, next let's go for the next question that we have. So they have given you some velocity profile where the components, the x component velocity is 2x by t and the y component velocity y is equal to minus y square t. So they are asking you for what's the streamline equation at the point 1 passing to the point 1 comma 1. Okay, so what's the equation of the streamline that's passing to the point 1 comma 1 is being asked. So you can write the streamline equation is dx by 2x by t is equal to dy by v, which is minus y square t. So you can just cancel this t, y by you can cancel. So this implies 1 by 2 log x is equal to minus ln y plus c. So if you perform a bit of calculations, we get root x into y is equal to constant, or xy square is equal to constant. This is the equation of the streamline that is with us, correct? So xy square is equal to constant, and they are asking you the value of the streamline which is passing to 1 comma 1. So if you put x is equal to 1 and y is equal to 1, your c value is 1. Because at x is equal to 1, y is equal to 1. So what's the final streamline equation here? Xy square is equal to 1 is the equation of the streamline that's passing to the point 1 comma 1 for the given flow situation. Clear? Next, they have also asked one question from COP of some refrigerator. So COP of a refrigerator is given 10. Then the refrigeration capacity or the refrigeration effect, this is given as 150 kilojoule per kg. Then heat rejection factor QR by 150. This is equal to 1 by 10, and this gives your heat rejection rate is equal to 165 kilojoule per kg. Okay, so the heat rejected from this refrigerator is 165 kilojoule per kg. So that's what we have. Next, we have one question from this newly introduced topic, that basics of compressible flow. So they are asking you for the velocity of the isentropic flow actually. So here there is some air which is a compressible gas, you know this, and of course this is an ideal gas. Then they are asking you for the exit velocity, I guess. Yeah, v is equal to 300 meters per second, That's okay. And T is equal to 300 Kelvin and P is equal to 180 kilopascals. And what about this CP? CP is equal to 1.005 kilojoule per kg Kelvin. And they are asking you for the stagnation temperature here. Correct? Yes, stagnation temperature. And you know, stagnation temperature at stagnation point, there is no velocity. So if you apply this, basic steady flow energy equation, we have Q dot minus W dot is equal to delta KE plus delta PE plus delta H. And since in the saturated state, whenever this is insulated, then definitely there is no heat loss. And also in this, all these terms, if you equate this Q dot to 0, W dot to 0, delta Ke dot, delta P dot and all, then definitely initial enthalpy should be equal to this final enthalpy. But of course, if this is the stagnation point, then the local velocity at this point is 0. So which means you can write, delta K won't be 0 actually. Let me emphasize, this delta potential energy can be 0, and of course this is the expression that is with us. So at the final point, since this is the stagnation point, there is the local velocity having 0 and initial velocity is 300 meters per second. So we can take this V as 0 here in this case. So if you substitute, we'll be ending up with the expression T stagnation is equal to T naught plus V square by 2 Cp, where V is this velocity at this point. So if you quickly substitute, we'll get the T stagnation temperature as, because Cp is known to us, V is known to us, T naught initial temperature is 300 Kelvin, that's also known to us. So if you substitute, we'll be ending up with 374.77 Kelvin. Okay, so 374.77 Kelvin is the answer for this question, which is asking you for this stagnation temperature. Okay, so T stagnation in this case is 374.77 Kelvin. Next, let's go for the next question quickly. So there is one question from mathematics. They are asking you for Laplace inverse of s plus 3 divided by s plus 1 into s plus 2. Correct? So this is what we have. So if this is the case, then there's two methods. One thing, you can split this into partial fractions, and of course, since they are asking you for f of 0, we can write this is equal to, by final value theorem, by the initial value theorem, we can write s into f of s. This is what you can write. So this is limit s tends to infinity, s into s plus 3 divided by s plus 1 into s plus 2. So definitely, since if you multiply these two things, you get a s square term with, of course, coefficient 1. Similarly, if you multiply these two, you get a term with x square with coefficient 1. So the value of this limit is nothing but 1. So this f of 0 is equal to 1. That's it. Okay, it's a simple question. Of course, you can do it in partial fractions way also if needed. Next, there is one other question from mathematics. They are asking you for 1 plus I whole power 8. So this can be written as 1 by root 2 plus I into 1 by root 2, or I by root 2 whole power 8. And this is equal to root 2 power 8, which is 2 power 4 into 1 by root 2 plus I into 1 by root 2 is 6 pi by 4, and 6 pi by 4 whole power 8. By De Moivre's theorem, this is 16 into 6 8 pi by 4, and this is 6 2 pi, and 6 2 pi value is nothing but cos 2 pi, which is 1, plus sin 2 pi, which is 0 into I. So this value is 16. Okay, so 1 plus I whole power 8 will give you 16. Clear? Next, there is one question from Newton-Raphson method. So f of x is equal to basically x cube minus x minus 3 is equal to, okay, this is the equation. Basically, we need to find the solution of this equation, and the initial approximation is given as x naught is equal to 2. And they have also mentioned the scheme Newton-Raphson iteration. So iteration is what they are mentioning, and of course they are asking you for x2, second iteration value. So in Newton-Raphson method, we have this iteration formula xk plus 1. The value of x obtained in the k iteration is nothing but xk minus f of xk divided by f dash of xk. This is what we have. So initially, by taking the initial guess, x naught is equal to 2. So if you try to simplify the equations, xk minus f of xk is something like xk cube minus xk minus 3 divided by 3xk square minus 1. Okay, so this is what we have. So xk plus 1 is equal to, let us write the final iteration scheme. So 3x cube minus x cube, which is 2xk cube, then minus xk plus xk gets out. So plus 3 divided by 3xk square minus 1. So this is what you have. So you can substitute this value generally. So x naught is equal to, you can put 2. If you put x naught is equal to 2, you will get value of x1. Again, if you put x1 is equal to the value which you got in this iteration, you will get the value of x2. And the final value that you get after the calculations could be something like 1.673. So this x2 in this case is 1.673. A quick approach, but of course this is the correct thing. Next, yeah, there is some flow over a solid plate. So we have a solid plate, and on the top of solid plate there is some fluid also. Okay, let us use some different color for the fluid. Okay, so this is what it's given, fluid and solid plate, and this is fluid. That's okay. Then there is some temperature profile that's given. So let us try to draw the temperature profile also. So if this is your y-axis, so the temperature profile is something like T is equal to 300 plus 200 into e power 5 minus 5y. So this is basically some function of y. So this is what is given. But if you take at the interface, whatever the heat that's getting, look, if this is the solid liquid interface, then definitely whatever the heat that's getting conducted to the solid will be the same that's getting conducted to the fluid at this interface, correct? So we can write minus k solid area of solid into dou T by dou y. Since this is only a function of y, you can write dt by dy straight away at y is equal to 0. This is for the solid case. This should be equal to minus k fluid AF, area of cross section in the fluid side, into delta T by okay, since this is again a function of y alone, so we can write dt by dy at y is equal to 0, and of course this is for fluid. Since the area of heat transfer is same in both the cases, so Kas, what they are asking you for in the question, so they are asking you for the temperature gradient of the solid surface at y is equal to 0. So finally, if you substitute the values that are given to you, you will end up with something like dt by dy at y is equal to 0 on solid side. This is equal to 10 Kelvin per meter. So this is what we have. Okay. So 10 Kelvin per meter is what you are getting, because Kf, Ka, all these are given in the question. Yeah, they are given, and of course you can calculate dou T by dou y at y is equal to 0 on both sides. Okay, on the fluid side basically, because this temperature profile is on the fluid side, so you can just calculate this. So you'll get just dt by dy at y is equal to 0 at solid side. Next, there is one question from the heat transfer as well. Heat exchangers. So heat exchangers, there is some heat exchanger with T cold inlet temperature is equal to 300 Kelvin. Then mass of cold fluid is mass flow rate of the cold fluid is 100 kg per second, and of course U overall heat transfer coefficient is 1500 watt per meter square Kelvin, and net area of the heat exchanger is 400 meter square, and they have also given TH inlet is equal to TH outlet. Both are same, which means there is some phase change that's happening inside this heat exchanger. So definitely if you take, there is some hot fluid that's passing, which is THI, and this is THO, and of course when hot fluid is passing in this way, and there is some cold fluid which is entering. So anyhow, so we can just take this direction at random, because since phase change is happening, so temperature difference could be the same anyway. I mean LMTD could be the same anyway. So you can just take this TCI as something which is equal to 300 Kelvin. Okay. Anyhow, so if this is the case, and this is TCO. Finally, what they are asking you for? They are asking you for outlet temperature. So TCO is what they are asking you for. That's okay. Next, to get this, we have one thing. We have U, we have A, and of course we have the mass flow rate of this cool fluid also. So we can calculate NTU directly. NTU is equal to UA by C minimum. So specific heat in minimum quantities, and this fluid specific heat is also given, Cp of cold fluid. Cpc is equal to 4000 joule per kg Kelvin. That's okay. Then that's enough to calculate this NTU. So finally, if you substitute your A and C minimum is basically the multiplication of this with this, right? So m dot C into Cpc, which is the heat capacity rate. So 100 into 4000, which you can write here, and UA, you have some values. U is 1500, A is 400. So if you substitute all these values, you get NTU as 1.5. And what is the effectiveness of this heat exchanger, in which there is some phase change? 1 minus e power minus NTU. So definitely you can write 1 minus e power minus 1.5, and this will give you something around okay, anyhow, this value we can directly equate it to effectiveness is nothing but this cold fluid outlet minus inlet divided by THI, which is 350 minus 300. So if you equate this equation from this equation, you can get the value of TC outer. And what's the value of TC outer that you are getting? So TC outlet temperature, this is equal to 338.84 Kelvin. 338.84 Kelvin is the cold fluid outlet temperature that you are getting here. Fine. So 338.84 is the outlet fluid temperature that you are getting in this case, but of course all these are simple calculations that could involve. And you know what's the meaning of effectiveness? Actual, at the maximum, what is the heat transfer possible in the denominator, and what's the actual heat transfer that's happening. Next, this is just a key session. So there is one more question from Rankine cycle. So feed water heaters and all. So basically it's some regenerative Rankine cycle. So some data is also given here, and from this we can just calculate mass flow rate of steam. So some feed water heater is given. Okay, so some feed water heater is given. So there is some steam that's coming into this m dot S, of course, and the enthalpy at this stage is H2 is equal to 2624 kilojoule per kg. This is what we have, and of course some energy inlet to this source is also there. M dot is equal to 100 kg per second of water is coming, and of course the enthalpy at this stage is 226 kilojoule per kg, and of course here total it should come out. So this is H6 is equal to 708 kilojoule per kg. So this is some data that's given in the question, and of course if you apply the energy balance for this feed water heater, you will end up with the mass flow rate of the steam as M dot S is equal to 25.15 kg per second. 25.15 kg per second is the mass flow rate of the steam that's entering this feed water heater. Because in regeneration what happens, generally you bleed out some steam from the turbine and you send it for the regeneration, correct? Means to basically increase the enthalpy of the fluid that's on the other side. So definitely fine. So eddy viscosity is directly, that's for the Reynolds stresses that's take place. So there is one tank and there is an aperture at this opening, so there is definitely some fluid flow out of this. So given this dimension is 1/4, and this totally is 1. This can be shortened a bit. So this is the tank that we have, and of course the liquid level is still here in the tank. Okay, so they are asking you for the time basically. So time we have T. For the time we have the formula, this area of this tank divided by area of this orifice into square root of 2/g into root of H1 minus H2. This is the direct formula that you can apply, and you can just calculate the values. If you calculate, time T is equal to 2258.76 seconds. I think you have the option for this. Next, Mach number question is given. So Mach number is basically your actual velocity divided by the acoustic velocity, and acoustic velocity is square root of gamma RT. So you can find the actual velocity using this. V is equal to Mach into root of gamma RT. So you can just calculate this value. Mach number is given, temperature is given, R is given, gamma is also given. So if you calculate all these things, this is 0.6 into square root of gamma is 1.3 into 32 into 350. This is equal to velocity, you can just calculate directly 228945. Okay. So I am not performing any calculation in this case as I did for the mathematics course. So please try to take the answers. So you can check your answers. Next, there is one differential equation that's here. 1 plus y into dy by dx is equal to x. So into, okay, this is equal to y, that's given here. Fine. So if this is the differential equation, then it's an easy question for you. It can be separated into variable separables. 1 by y into dy is equal to dx. So initially after solving this equation and after solving the differential equation with enough boundary conditions, you will get the solution like y into e power y is equal to e power x. Okay, next, let's go quickly. So there is some question from probability as well. So in a box there are 15 blue balls and 45 black balls. So out of this, what's the probability of picking one blue ball and one black ball one after the other? So 15 by total number of balls initially is 60, and if the first pick is a blue ball, then the next has to be black ball. So out of this 45, you can pick anyone, and total number is 59. So this can be 4. So 45 by 4 9s are 36, and this is 236. So 45 by 236 is the correct answer for this. Next, in case of equilateral triangle, so in yesterday's exam there is one question. Basically, if there is a circle, of course this is an equilateral triangle actually, and there is one thing like this. So basically they are asking you for, if this is the center of the circle, then if this is R1 and if this circumradius is R2 actually, then what's the area of this larger circle divided by smaller circle, which is 4:1. Clear? Next, two clocks ticking at 10 a.m. initially, and clock 1 is taking 30 seconds for ticking again, and clock 2 is taking 32 seconds for ticking again. So then they are asking you for what's the maximum time again at they click together. So LCM we can take, LCM is 480. So 480 is nothing but 8 minutes. So again at 10:08 they tick each other. Okay. So the answer for this is 10:08. Next, let us go quickly. So the diagonal folds, of course, you know, they are 4 symmetric folds. So the answer comes 1/8 of the actual value. Next, fine. So in a binomial distribution, we have number of tiles as n and probability of success is p. Then you know mean is equal to np and variance is equal to npq. This is what we generally have. So this is the correct option, which is having this mean as np and variance as npq. And for the Simpson's rule question, we have one question of Simpson's rule. And the answer for this one, Simpson's 1/3 rule question, means basically this integration of 4 to 5.2 log x dx. The answer for this is 1.82773. I'm just writing the answers. That's it. I'm not giving any further explanations how these answers came, because it's just like checking your answers. Okay. So anyhow, next. So finally, there's one question for matrices also. So f of x is defined as half into x transpose into q times of x minus r times of x. Okay, so they are asking you what is the stationary point, and what's the meaning of stationary point? Your f dash of x is equal to 0. So after taking suitable size for n and all, you get this x as r divided by q. This is the stationary point at which you can have this maximum or minimum of this function. Next, let us go quickly. Eigenvalues of a square are nothing but lambda squares. So definitely you can see, if AP is equal to alpha square P, that means, you know, if P is a vector generally, then alpha square is equal to lambda. If eigenvalue of A is alpha square, then eigenvalue of A square, this is alpha power 4, because which is lambda and this is lambda square, which we know this. Okay, so that's what we have. And in thermodynamics, we have one more question. In a tank, there is a mixture of 20% liquid and 80% vapor, correct? So we have some 20% liquid and 80% vapor. So they are asking you for the final thing of what's the total mass inside the system. For this question, the answer is the total mass inside the system is equal to 135 kgs. Okay, so the answer for this is 135 kgs, and the answer for this is alpha power 4. Okay, next, let's go quickly for the other questions. So in thermodynamics, we have one more question. Like basically, there is some channel that's coming in this way, and there is some hot air inlet to this. So some air is coming in this way, and again some air is also leaving in this way. So basically, the flow of air is divided into two streams like this. Correct. So here there is hot air. M dot is 3 kg per second. P is equal to 100 kilopascals on this side, and of course T is equal to 340 Kelvin. Similarly, for cold air, we have here m dot is equal to 2 kg per second, pressure is equal to 100 kilopascals, and of course temperature is equal to 240 Kelvin. So they are asking you for the what is the total enthalpy change of this control volume. Correct. So you can take this as the control volume. Just I would like to draw for you. So this is the control volume, and you can sense that this stream is divided into two streams. So you can find the enthalpy change of this stream and this cold stream individually, and if you sum up, you can get the total enthalpy change of the control volume, and this is equal to 2.238 kilowatt per Kelvin. This is what we are getting generally. Okay. Next, there is one more question from fluid mechanics, that through a duct there is some fluid flow that's happening. Similarly, there is some fluid flow that's happening here. So if this is the case, then they are asking you for what is the discharge. Here the velocity is given 6 meters per second. So here the uniform flow is happening, and this velocity is 6 meters per second, and this is 0.32 meter. Expected cutoff could be something around 31. This year paper is a bit lengthy, so many students, they may not find enough time for solving all the questions. So I feel cutoff could come a bit down as compared to last year. So it could be 31 around. Okay. So next, this is 0.32 meter. Then they are asking you for what is the mass flow rate of the fluid in liters per second. So if you apply this, inlet conditions are also given. 0.01 meter square is the area that's going out, and 35 meters per second is the velocity at which the flow is happening. So we can just multiply area into this plus Q is equal to 0.8 into 6. So this area is A naught. Okay, so that's what we have. Next, so Q is equal to 132.5 liters per second. This is the answer of this question. So there is some flywheel question where torque is given. Torque is equal to 1200 plus 2500 sine 2 theta Newton meter. So for this question, they are asking you what is this I. Okay, so you can just calculate because all the other things are given. N is equal to 120 RPM. So which means omega is equal to 4 pi radians per second. Then coefficient of split is given, which is plus or minus 0.5%. So we can just calculate because total is 1%. So you know change in kinetic energy of the flywheel is equal to I omega square Cs. So we can just find all the terms that are right here. Anyhow, next, let us go for the next question quickly. So there is some question from the vibrations as well. So from vibrations, there is this question. Okay, so there is one spring, and this spring is also carrying some mass here. It is fixed actually. So this is carrying some mass M, and the mass of this pulley is capital M. So they are asking you for the frequency of this vibration, and of course omega n is nothing but root of S divided by M plus capital M by 3. So this is the correct expression for the omega n of this particular system when there is a small displacement in this mass M. Okay, next. This columns question 34, we have given a column with one fixed, with one hinge here, and also it's fixed here. So the critical load in this case they are asking you, the critical load value for this question is 800 kilonewtons, okay, which is pi square EI by L square, of course multiplied by 2 for this situation. Next, steel cube block side is 200 mm, hydrostatic pressure is given. They are asking you for reduction inside in mm. So for this question, in which hydrostatic pressure is given, this question we have this hydrostatic pressure is 250 Newton per mm square and all, and then we have the steel block side, this is also given 200 mm. So we know this bulk modulus is nothing but volumetric strain divided by the actual volume. So if you perform all these calculations, then the reduction inside we are getting as reduction inside, we will be getting this value as 0.1 mm is what we are getting here in this case. Okay, next, this truss question is given. So basically there is one truss, we can just quickly try to draw this. Then here we have a hinge, and here there is some roller support, and this is B. So they are asking you for FAC and FCD. FAC and FCD is what they are asking you for. Okay, so initially this is a hinge, so you have some horizontal reactions and also some vertical reaction, but here we have a roller support, that's it. So we have some, just if you call this points as AB, okay, CD if you call, then this is RD, this is what you will be having, and this is the force in FAC direction, and of course this is 45 degrees and this is also 45 degrees, that's what we have. So this is FAC cos 45, which is FAC by root 2, and this is FAC, anyhow this is also 45, so FAC by root 2, this is what we have. So we can just calculate the members, the force in the members EAC, which is like this, and force in the member CD as well. So FAC you will be ending up with and of course there is some force that's acting here, F. So if you equate these two, FAC by root 2 is equal to F, so FAC is equal to F times of root 2, and this is what we have. And of course FCD is equal to, this is the member in the CD, so F root 2 by root 2, which is minus F, which is compression in this. Okay, so this bar is having two members AC and CD, basically this is F root 2 and minus F. Next, So there is one question which is something like this. So this some force F that's acting on the bar. This is the force that's acting on the bar F. So they are asking you for the what is the vertical displacement of this point A. If this is the point A, and of course this is L, and so they are asking you for what's the point of deflection of this point A. So X A, what we have calculated from our side is 4 by 3 F L square by E I. Okay. So this is the value of the deflection that we are having in the vertical direction for this point A. Next, there is one cantilever. They are asking you area of the bending moment. So there is one cantilever. Okay. So and there is a point load here. This is A, B. So they are asking you for the area of the bending moment diagram, and EI is given. AB is also given. Length is given. So they are just asking you what is the deflection angle at theta A. So definitely after applying your load, you will be having something like this. So this is your theta A. So they are asking you for theta A. So if you apply this second moment area theorem, then definitely you can get this theta A, and this theta A is 50 microradians is what you will be ending up with if you perform this calculations correctly, because you know this theta B or theta A minus theta B is equal to area of the M by EA diagram between those 2 points. So you have all the values given. So just if you apply this first area moment theorem, you can get directly the value of theta A. Next, there is some question from inventory control. So the question from inventory control is P is equal to 3 into 10 power 4 per day and all. So for this question, the answer is 4249.22 units. This is a question from inventory control basically. So from this inventory control for this question, the answer that we are getting is basically this estimated order quantity. This is equal to 40249.22 units. That's what we have. Next, so allowance definition: lower limit of nut hole minus upper limit of shaft, because that's the actual allowance. So basically, when you're having a nut and shaft assembly, then definitely the lower limit of the nut hole minus upper limit of the shaft will be the clearance in between them, and that's the allowance definition for that. Next, there is one question from this number of cycles dynamic loading basically. So endurance limit is given as 150 megapascals and fatigue strength per 1000 cycles, and this is the endurance strength for 1000 cycles, so 10 cube cycles. Next, this endurance strength has got to 450 MPa, number of cycles are 200, number of cycles for plus or minus 200 MPa. Okay, so endurance limit is 150 megapascals, and for 1000 cycles the endurance strength has 450 megapascals. Okay, so this 450 MPa is for 10 cube cycles. Then for they are asking you for when number of cycles for plus or minus 200 MPa. So for 200 MPa, what are the total number of cycles? This is what they are asking you for. So we have this SN diagrams. So if you draw this SN diagrams properly and calculate, you are getting this number of cycles as N is equal to 1636.32.47 cycles. This is the number of cycles that you are having for endurance strength of 200 MPa on this. Okay, and next, so this is what we have already given. Next, there is one question from this wedge and block. So wedge and block is again a topic that was introduced for GATE 2021. So definitely let us try to have this diagram. So there is some plane at 30 degrees, and there is one block sitting on this plane. Okay, there is one block that's sitting on this plane, and the weight of this block is 500 newtons, and of course this block is also supported by 750 newtons. So they are asking you for what's the coefficient of friction on this wedge. So if you apply simple static equilibrium of all these things, you get mu is equal to 0.1728 for this question. Okay, and I'm again repeating, this is not the detailed session solution, detailed solution session. It's just the answer key session. Okay, so that's what we can have. Next, input analysis, project evaluation review technique. So we have 9 activities with sigma is equal to 3 and variance is equal to 9. So they are asking you for standard deviation of P, standard deviation of the project. So they are asking you for the standard deviation of the project, and of course for 9 activities we have sigma is equal to 3, which means your variance is equal to 9. Sigma square is equal to 9. Correct? So variation of the project is equal to summation of variation of all the activities. So this is nothing but 9 times of 9 activities are there totally. So this is 81. So variance of the project is equal to 81. That means your sigma P is equal to square root of 81, which is 9. So 9 is the correct answer for this. Is it 9? Yes, it's 9. So let's go for the next question. So diameter of the nugget, and again welding question is given. So for the power required for the welding, so this welding question where some nugget is given. So for the welding, the power required is I'm just giving you the answer for this. The power required for this is 39.27 kilowatts. Is the answer that we got when we calculated finally. And of course, yes. So there is one last question. Okay, there are a few more questions actually from acceleration of the system, and also we can see that there is one wheel that's getting rotated about this hub, and also the side view of this wheels is also given. So this is wheels, and there is one axle connecting these wheels, and of course there is one more wheel. And this is moving on a straight road. So they are asking you for what is the acceleration of the system. So acceleration is equal to r into alpha. So if you apply a bit of, yeah, we know that summation of momentums is equal to inertia into moment of inertia into angular acceleration. So I alpha. So from this you will get alpha, and you know what is the radius of the wheel. This is given already. So you'll get this acceleration or tangential acceleration at is equal to, this is at actually, this is 1.65 meters square per second, or meters per second square. This is what you are getting. Okay, 1.65 meters per second square. So this is what we have, and for this question, wheel axial question, and of course some instantaneous centers question is also there. So for instantaneous centers question, I could like to show you something. We could like to plot all the instantaneous centers of a given mechanism. So you could clearly sense there is some hinge here, and there is some crank and other elements here. So okay. And the instantaneous centers, of course, are the lines joining all these things. So let us try to do that. So this is one instantaneous center that you have here, and again this will be one more instantaneous center because two rings are again meeting at this point, and again this is the axis. So this is one more instantaneous center. So you can have all this, and of course along this line, on this line you will be having somewhere here in the instantaneous center. So these are 4 instantaneous centers for this mechanism that's available here. So you can choose any one of this. So they also ask for time for solidification of a casting. So time for solidification, of casting. You know this time for solidification is directly proportional to volume by surface area square of the casting. So if you do the things that's given in the, if you just substitute the things that actually given in the exam, you could get the time is equal to 2.78 seconds for the casting to get cooled. Okay, next they have given you some sine bar. So sine bar question. So in the sine bar question, they are asking you for the total height of this bar. So this total height is equal to 127 plus 76.2, which is 203.2 mm. Is the total height at which the ball is located. Okay, so this is what we have from our side. These are the questions that we collected. I just gave this session because to enable for quick checking of answers. Okay, because detailed solutions are already out by many others. So just I would like to give you the key for quick checking of your answers. That's it. Okay, anyhow, thank you all. Have a nice time. All the best for future. And whoever didn't do well in GATE 2021, please don't waste your time. Please start preparing from today itself, because there are a lot of exams which are recruiting apart from GATE. I mean, without using GATE score. Okay, so please keep preparing and try to be in touch with the subject. Thank you all.